we're in week, I think it's 29, wherever it is, we're going back and reviewing logarithm skills. All right, logarithms are important for higher level math, right? So therefore, it's something that you can't just do and then forget about it. And too much of the Algebra 1 that you had, you did it and then forgot it, and so when you got to Algebra 2, you had to relearn it. Right? You've got to stop doing that with some of these skills. All right, now, there's going to be some changes. In 610, right, you're going to do the quick 10. That's a good review. You should always do those. They shouldn't take that long. And then I want you to do 19 to 49 odd. You've already done the even numbers. Okay, 19 to 49 odd. These will go pretty quickly. Right, but that's a good skill. About half of these are test-worthy problems for SAT. Okay. Then in section 611, which is base changes, and again, we've been doing base changes for a long time. I think it's one of the skills that you should be comfortable with as far as logarithms are concerned, because if you see two different bases, then you're going to take in the calculator, you're going to take the log of the number divided by the log of the base, and you have the answer from the calculator. So, so that base changes, you're going to do odd 1 through 15. And then for section 612, which is inverse functions, we're going to talk a bit about that today. Inverse functions, you're going to do the odd number problems, which will be 1 to 17. All right, then 13 is not going to be tested, so don't worry about that. Okay. All right, questions on those? All right, okay, now, all right, so now again, this is review, but these are the logarithm functions that are part of this section. All right, now, there's a thing that's called a product rule. In the product rule, if you have two numbers that are multiplied together, in this case, x and y appear to be different, right? So therefore, you can break them there because logarithm is an exponent, and that is a testable question. A logarithm is what? An exponent. That what happens when you have the two exponents in a product is that you add the exponents. So therefore, this logarithm is an exponent, and that logarithm is an exponent, and you add them together. All right, now, I did a different example because it's obvious these two have to be done that, but what happens if you have a 15? You can break any product into two numbers that equal that product. Right? And so, because 15 is 5 times 3, the log of 15 will be the log of 5 plus the log of 3. Okay? And that's my way of understanding what the product rule is. Okay? Now, quotient rule is the same thing. If these two are divided, then you're going to take the log of this minus the log of that, because that's what the exponents do when the base is the same. In this case, the base is base b. Okay? All right, so let's say you have 7. Well, 7 is equal to 14 divided by 2, isn't it? So therefore, the log of 7 is equal to the log of 14 minus the log of 2, because those are the exponents. Okay? Now, all right, log of a power. Log of a power says that if you're taking this to the y power, now you think of this, what does x to the third mean? What's x to the third mean? Doesn't it mean x times x times x? Yeah. So you're adding 3 of the same things together. Well, what's a quick way of adding? Multiply, right? And so what happens is this power, or exponent, comes to the front because I have this many, now look at what I'm saying, I have y many of these x's. So I'm going to have y times the log of x. Okay, you think of it this way. The log of 8 is equal to what? What does 8 equal as a power? Does it equal 2 to the third power? So therefore, I have 2 times 2 times 2. And if I do that, I could say log 2 plus log 2 plus log 2, but there's a faster way. And that is to say 3 times the log of 2. Alright? And then the base rule, change in base rule, is the one that we've done. So the log in base 3 of 27 means take the log of any base of 27 and divide it by the log of the same base of 3. Now, in our calculator, we have base 10 and we have base e. That's what the ln is. So either one, provided you keep them the same. So I could say ln of 27 divided by ln of 3. Okay, yes. Okay, question? All right, so those are the rules that are in a normal logarithm type of question. All right, so then what we're going to have to do is we're going to have to figure out, okay, what is the question, what is the equation asking us to do, and what skills do we know that we're supposed to use? Okay, so you have those down, and now I'm going to go to another sheet where I have some other work.
Wait, Mr. Belcher?
Yes, yes.
I'm still writing down the last one.
Oh, okay, sorry. Thank you for stopping me. That takes some courage to do that. Say, hold on, I'm not quite there. All right, got it?
I'll let you know.
Okay. All right. I constructed this morning, or if I'd done it a few days ago, I would have made a printout for you. But this was just put in this morning. Okay. All right. Now we go to the fun part. Okay, now, so this is stuff that you've already done, but it's important for looking at logarithms. All right, the definition of a logarithm is a transformation of an exponent. All right, logarithms and exponents are inverse functions. Okay, so if you have some base number raised to the e power and it equals a number, then by definition, log of base b, which is this number, so the log of base b of the number n is equal to the exponent. Okay, and again, what did I say was a testable question?
Logarithm is an exponent.
Logarithm is an exponent. Okay, now, the identity rule says that log base n of n to the x equals x. All right, what if you have, let's say 4. If I have 4 equals 4, what's the exponent? 1. And so when I change it to a logarithm, because the log is an exponent, the log base 4 of 4 is the exponent 1. That makes this the exponent 1. And so I have 1 times x. And you can use the last rule that we did with some number to this power. Remember it said x to the y power is y times log of x, but log n of n is 1. So this would become x times 1, or just x. Now when you're solving equations that have logarithms, sometimes you have to add this part. You're given this, n to the x. To be able to get at the x, you have to be able to say log base n of n. Now the other one is the one that we've been working with a long time. If you have two different bases, then you take log of the big number divided by log of the base. Okay? Now, hopefully that's going to stay there as we scroll these things up. Alright, now here's the first problem. Okay? Now, you're given this, and the first thing, I don't know the answer, do you?
Yeah.
Now, I personally know that 3 to the 4th power is 81. Because 3 times 3 is 9, and the other 3 times 3 is 9, and 9 times 9 is 81. But if I didn't know that, then what I'd have to do is change this to a logarithm. And I would say log base 3 of 3 to the x equals, so this right here is, I didn't change it. I just went at it by adding logarithm, which is this rule, the identity rule.
Yes.
Right? So I took log base 3 of 3. Why did I do that? Because log base 3 of 3 is 1, and that gets me to the exponent. Right? So if I take log base 3 of this side and log base 3 of this side, I have x minus 1. So x is going to equal log of 81 divided by log of 3 plus the 1, because I have to take this 1 to the other side. And all of that is calculator work. Don't worry about putting them in the calculator. We have already, we've already practiced doing calculators. Right? And when you do the homework, you'll have another set of practice. But I want you to begin to see what you've got to do before you put the calculator in. Okay? All right, so that takes care of that part. So here's a similar example. You have to get the x. So you're going to use the identity rule and say log base 8 of 8x, that equals x. And then here on this side, log base 8 of 4. So what do you put in the calculator? Log 4 divided by log 8. You don't have a choice. That is the change base rule. All right? Question? Pretty simple, isn't it? Because we're smart. Okay. All right, now let's look at the next one. Now this one isn't used that much with Forrester in our book, but log base e, that is ln on your calculator. Not log, but ln. That's the natural log. And e is 2.7 something. Right? But anyway, you normally have to use a second function and then a button to be able to get this. But again, because this is base e and ln is base e, this is log e of e to the x power. So that side's x. And what would you do with log ln 5? Now this I do want you to put in the calculator because we haven't used it this much. Put ln 5 in your calculator. All right. Now I know that e is 2.7, a little bit less than 3. So 3 to the second power is 9. Because this is 5, I've got to be 1 point something. Would you agree with that? Okay, so from a logic standpoint, that's true. So, look at what I got in there. Get rid of that. So I want ln of 5, and I get 1.609.
Yep.
Okay? 1.609. Now, so therefore, if I go back here, if I take e and raise it to the 1.609, I'm going to get close to 5. Okay, so let's do that in the calculator so if we had to check it. So how do you get e to the x on your calculator?
I press the second.
Second.
ln.
Second and ln is the one I've got too.
Yes.
All right, so how does the HP work? You should see e to the x as in the brown, I think, right?
No, I got it.
Okay, so now we're going to put in 1.609. We're going to raise e to that 1.609 power, and when you press enter, you get 4.997 is what my calculator says. Okay, how come I didn't get 5?
Because we didn't use the whole decimal place.
That's right, and because when I called through the 9, I chopped off the 4 thousandths, right? And so because I chopped off the 4 thousandths, I'm going to be a little bit less than 5, but not much less because notice it's 4.99. So I'm still within 100th of the correct number, which is pretty good accuracy. Okay? All right. Now, so then we look at problem 4. All right, this is ugly. Now, the only problems that we know how to work with are when this is the only thing that I've got. Right? So what do I have to do with the 14?
Add
You gotta add it just using algebra. So when I add the 14 over here, I get 25. How can I get rid of that 3? Divide. So I have e to the x equals 25 divided by 3. Now this, I can get at the x by taking ln. And had this word, instead of e, had it been a number like 5, then I would have put log 5 of 5. But because e is a special, has a special case, I'll take ln of this side and ln of that side. And so the value will be the ln of 25 divided by 3. Find it. Two point 12.
Yeah.
All right, 2.12. All right, you could, 2.1202 would be good.
Yeah.
2.120, but 2.12 will work, right?
Yeah.
Okay, everybody get that?
You said 02, but I got an 03. That's
Okay, because it's 2.6, so your calculator is rounding to the 4th decimal place, which is okay. That's good. All right, now, because you have 03, all right, Sydney, when you put that in, you're going to be a little bit greater than 11 when you finally put this in. Because your calculator rounded it up for you. Okay. All right? Okay, question? Okay, now, how hard was that problem?
Okay.
How, not hard? That's a college level entrance exam problem.
Cool.
Okay? And so the point is, if you can do it, you can do it. Right? If you can't do it, you can't do it. And what the entrance exam is wanting to find out is how well you understand logarithm equations. Right? If you can, you can. Right? But the same thing is true with everything in algebra that's tested. Right? A good test is going to find out whether you can do what they think you ought to be able to do. And what happens if you can't? Then you have to either go back and be retaught, or you have to go practice and then take the test again. All right? But a good exam like this is trying to find out whether or not you have the good base in logarithms so that you can continue when you get in the college class. Okay? Same thing would be true for going to Algebra 3. If you can't get close on this problem, then you're probably not ready for Algebra 3 either.
I wasn't ready for Algebra 2.
Yeah, okay. Whoa, what happened? That's weird. Okay, now, all right, I skipped this one, number 5, just because I didn't want to get all of them in there. All right, this says minus 6 ln equals 0. Okay, but all I can work with is this. So what do I have to do? Right? I've got to add 6. Then I have ln of 3x, which is ln of 3 plus ln of x. Right? Because that's what we're learning today. Okay, so we're going to move on. Okay, so let's look at the next one. All right, what's the base of this log? The base 10.
Yes.
Right? So I could have had a little 10 in here. Right? We don't do that because this is the base of our calculator system. So that's the base 10. Now, in this particular problem, what is the 2? All right? In any logarithm, the log is the exponent. So that's the exponent of the 10. That's the key to solving this problem. Okay? And the reason that you have to know how both, if you have an exponent problem, you can take the exponent expression and change it into a logarithm, but you also have to be able to take a logarithm problem, change it back into an exponent. So now this says 10 to the second power, which is how much? 100, right? Equals this value here, because that's the big number. So I have 10 to the second power equals 3x plus 1, and so now I have a simple algebra problem. right? But the Algebra 2 skill is knowing how to change this into an exponent before you start. Now, if I would have given you this problem to do, just like it is, could you have done it? Would that have been a tough Algebra 2 problem? It really isn't, but again, you have to just go at it. So 100 subtract 1, 99. If 99 is equal to 3x, then x is equal to 33. Okay? Alright, so, alright, now let's look at the next one. Alright, again, if you don't know what ln of x is, then we really can't do much, so we have to change it, right? Okay, so, you see this minus sign? What does it mean? That the exponents were divided, so I have x divided by 3. X divided by 3. Now, if I had the ln of x divided by 3 equals 4, what is 4? The exponent of base e. Because that's ln, right? And so I take e to the 4th power equals x over 3. Now, e to the 4th power is a calculator number.
54.59.
And then what am I going to do with that 54? I'm going to multiply it by 3.
3 equals
163. Yep.
0.7944.
See it? You get it or not? You need to do this. Okay? So you take e to the 4th power. Okay, that's just a number right now. Had this not been ln base e, if it would have been log base 5, then this would have been 5 to the 4th power instead of e. Right? So if I would have had this, log base 3 of x minus log base 3 of 3. There are several ways to go at this, but if we follow the same thing, this is x divided by 3, but the base is here. So I would have 3 to the 4th power equals x divided by 3. Again, so what we did, let me go back here. What we did right here, because this is base 10, we said 10 to the 2nd power, right? You're going to do that with any of them. Now, all right, let's look at this one. What does this say? 5 to the x plus 2 equals 4. All right, if I've got to do that, I have to take the base of, hello? If I say 5 to the 4th power equals the exponent, right? So, in this case, I have 5 to the x plus 2 power, that's this, equals 4. Right? So, if I have this, I take log base 5 of the number equals the exponent. I can set it that way too. Now, log base 5 of 4 is a base change. It's log of 4 divided by log of 5. Then, what do I do with this plus 2? Subtract 2. Okay, so let's do that one. In your calculator, do log 4, close the parenthesis, divided by log 5.
Negative 1.136.
All right. Okay, well, when you do log 4 divided by log 5, you get 0.86. And then when you subtract 2...
Oh, I just put it on.
That's right, yeah, you can put it all in at once.
Yeah.
Then you get negative 1.1386. And if I were doing it, I would go to the 4th place and then just cut off the 4s. I like to truncate rather than round. All right, you see that?
Yeah.
Okay, now again, is this a high-level problem? The answer is yes. This is a high-level problem, right? So we're working at the top of the skills for logarithms, right? But here's my point. How difficult is that on a scale of 1 to 10? Well, it may be a 4,
Yeah.
a 4 or 6. It certainly isn't a 10, is it?
Yeah.
No.
Right? It's not a 10. There is work involved. Right? But what I'm trying to show you is with the basic skills remembered, then you can unlock these problems. Okay? All right, now, so that takes care of those. Now we've got another, I've got several sets of these, so don't think we're going to run out. Okay, and I can't do this like I want, so I'm going to have to leave that there. Okay, now what do you see here? All right, by definition, log base 4 of 2.5 equals -3, right? All right, log of 0.25 equals -3x. Now, this is a number. All right, Carissa, how do we do this part?
Divide the log of 2.5 by the log of 4.
Very good. Divide the log of 0.25, right? Divided by the log of 4. That will do that part, and then what do I do with this? Is this multiply?
Divide the 3.
Then divide by -3. Okay? So that's going to be log of 0.25 divided by log of 4 divided by -3. And it will give you the value of the x.
3.33.
Yes. Okay, now look at this. 4 to the second power. 4 to the second power is 16. That's going in the wrong direction.
Yeah.
This is less than half. So it's between -1 and -2 because it's between 1, 4. Well, that is 1/4, isn't it? So what do I multiply that by to get 1? All right, there's other ways to do it, but we're using logarithms. Okay, now let's go to, I'm going to drop this. I hate that. Let's see, can I do it this way? No. Do it like that. I can't move it. What's wrong? Oh well, we'll take it right there. Okay, log 7 of 3 plus log 7 of x. Now this is the new set of rules. This is a product rule, isn't it? So what two numbers get combined? 3 and x. Log base 7 of 3x. Now what does it equal? Log base 7 of 32. In order for those two to be true, then 3x has got to equal 32. That's another common sense, right? If the bases are the same, then this number has to equal that number, because it says it does. Right? And so you're solving 3x equals 32, and so x is, very simply, 32 divided by 3. Okay? Now, what was the key to getting to that easy algebra? It was knowing what this means back here.
Right.
Okay? Because these are both logs of the same base, then the addition of the exponents means that the numbers were multiplied. That's why that becomes 3x. Okay? Now, all right, this one here. See that 2? I divide both sides by 2. Get rid of that. All right? Now, I have log base 6 of 4x. So this says 6 to the 0 power equals 4x. Right? 6 to the 0 power equals 4x. That's changing the logarithm back to an exponent. Now, anybody know what 6 to the 0 power is? 1. Okay? So how am I going to find x? I'm going to take 1 and divide it by 4. And if I take 1 over 4, I have 1/4 or I could have 0.25.
Right.
All right, now, what was the key here? Clearing the coefficient of 2. Now, it turns out that 0 divided by 2 was still 0. It wasn't that I threw it out, it's that I got the same value. And then when I have this part, I'm going to change that into an exponent form. 6 to the exponent power equals the number. Okay, so let's look at 15. Is this going to be the same type of problem? All right, so what do you see here? See the plus? See the plus? So it's going to be this times this. So what is x times x minus 3?
X squared.
X squared minus 3x. Now, 2, this is the base, 2 to the second power equals x times x minus 3. And now we have a quadratic function. What is x squared, or 2 squared?
2 squared
It's 4. So that says x squared minus 3x minus 4 equals 0. And what are the binomials going to be? I know I have to have x here and x here. All right, factors of 4 that when you subtract them, you end up with negative 3.
1, 4.
Has to be 1 and 4.
Negative 4.
And negative 4 to make the negative 3 and positive 1 equals 0. So now x is negative 1 and y is, and x is 4 on that one. Now, in the SAT prep class that we're doing, this particular problem, if you were coding it in, it would say, what is one of the solutions? All right, and then you would either have to code in a negative 4, or I'm sorry, code in a negative 1 or code in a 4. All right, and we're having a problem like that in class today. Okay. All right, now, how hard was that? All right, you're shaking your head. All right, on a scale of 1 to 10, that's at least a 3. Because you have 3 different skills involved. You have the interpretation of the sum, right, which is the product rule in reverse, right? Then you have to convert it from logarithms to exponents, and then you have to solve the quadratic equation, which means to do that skill, which is really, I consider that too. So you have 4 skills there. 4 different skills is a difficult problem. Now, was it beyond your ability to do? No. No, because you're good math students. Now, if you were in 4th grade, I wouldn't expect you to do that. But I might expect you to know what this means.
Right.
Right? So sometimes you can teach some of this by rote, but when you get it as complex as that, you've got to be at a certain age level or a certain maturity level before you can actually do the work. Okay, now what do you see here? Again, you see the minus? What's that mean?
So, divide.
Divide the number. So this divided by this, which is right here. And then the base is 2. So 2 to the 3rd power. Why? Because logarithm is an exponent. So therefore 2 to the 3rd power equals this divided by this. Now what is 2 to the 3rd power? 8. Okay. So if this is an 8, how do you solve it? This is the trick. How do you solve it? What's the first step? Clear the denominator. How do you clear this denominator? Okay, if I set it up like this,
Multiply by the reciprocal.
well, yes, you multiply by the reciprocal, so that'll be up there. And if I multiply this side by x minus 2, then I have to multiply this side by x minus 2. So I get 8x minus 16 equals x plus 5. Okay, what do I do with the x on the far side?
On the 5. So bring it over.
Bring it over, and so when I subtract it, this will become 7, and then what do I do with the 16? Add it, and so 16 plus 5 becomes 21, so if 7x equals 21, x better be tree.
Tree.
Okay? So here on Earth Day, we have a tree as a problem. Answer. Okay. Alright, so now that right there is probably the most difficult problem that we've had so far. Right, but the skills are knowing that this means divide the numbers, right? And then we have to take and change it into an exponent form. So I'm going to take 2 to the 3rd power equals whatever that fraction is, and then from there you have an Algebra 2 equation to solve. Okay, now, all right, so what do you see here?
Subtraction.
All right, so Cindy, what am I going to do if this is a minus sign?
Divide.
Divide what?
The x and the 6.
X divided by 6. So now I have x divided by 6 on this side, and if you remember, one of the rules is that the 2 here becomes the exponent inside. So I can put it back there. So x minus 6 equals this. Now, why are they in blue? Why are they in blue? Because why? Alright, why are they in blue? Because this has to equal that for those two logs to be the same.
Ooh.
Okay? And so now we have x divided by 6 equals 16. And so how do I find x? 16 times 6, whatever that is.
It's a big number.
I got a calculator that I paid to get that. I don't do that one on my own.
96.
Okay, so then see, and the 3rd grader that we hire, we tell them to put 16 times 6 in the calculator, and the 3rd grader will get the answer.
Can we hire a 3rd grader?
16 from. Oh.
Okay, good question. Good question. Okay. All right. Okay. All right. All right. Okay. So now we're going to do some where you have to work. I did all that stuff in the computer last night.
That's a lot.
So that was a lot of work, but I love you guys, so I did it. Okay. All right. Now, so here's our problem. All right. This is an exponent form that can be changed into a logarithm. What's the logarithm form of this?
Log 2 of 64.
Log base 2 of 64 equals x. Now, when you have this, we have a rule.
Yes.
What's the rule?
Log 10 divided by log 2.
Log
Oh, 64.
64 divided by log 2. Okay, and does that calculator work?
Mm-hmm.
Okay, get it. Get the answer.
I'm still not. What was the last one again? I can't. What was the last one again? The answer.
Okay, well that's because you weren't here last week. If you'd been here, instead of laying out 6.
I got it.
Okay, no wait, what'd you get?
6.
6. Okay, now, so how do we know that that's right? How do we know? Okay, I already just said she got x equals 6. How do we know that's the right answer? Go back here.
Plug it in.
What is 2 raised to the 6th power?
I said 6 raised.
If it's not 64, then we made a mistake.
It's 64.
Okay, so therefore, if I had given you this problem on the test, would you worry about it? Well, no. After you got the 6,
Oh, yes.
right? After you got the 6, if you put it back in here and prove that it worked, right, which is called checking your answer.
Yeah.
Right? Is that ever done in algebra?
No.
It's always supposed to be done in algebra. All right, one of the interesting things, I love teaching Algebra 1 because the homework in Algebra 1 we never checked unless somebody couldn't get the right answer. So at the most we would check 1 or 2 problems, and I really wouldn't have to teach because as soon as somebody said, I got problem with number 4, I couldn't get number 4 to work out, then somebody in the class would chime up that did the problem, and they would chime up and say, well, did you? Oh, I see. You know. But again, algebra is fun in that regard because once you get the answer, you can go back and check your work. Okay? All right, so what do we got the next one? Okay? 5 to the x equals 25. Now, I would not do that problem. Why? Because it's a math fact, right?
Yeah.
5 to what power is 25? 2, right? But if we didn't know that, then we take log 5 of both sides. And we'd have log 5 of 25 equals log base 5 of 25, because that's the exponent, right, equals x. Now, what happens when you do this? What do we do here?
Oh, you take log 25 divided by log 5.
All right, do it. Take log 25 divided by log 5. All right, you're supposed to do it too.
2.
All right, get 2?
Those.
All right, now, why am I wanting you every so often to plug it in yourself?
So you check it.
Because that's your experience, right? And when you get the experience of pressing those buttons and coming up with the right answer, when you have to do one on a test, you're going to at least know that if I do it right, I can get the answer.
Yes.
Okay. All right. Okay. So now we're going to go to a fun one.
Yay!
Okay. Now.
Great.
Okay. Here I have what kind of form? Exponent form.
Exponent.
Okay. So therefore, the exponent form can be changed back into a logarithm by saying
log base 3 of 81.
log base 3 of 81 equals x minus 2. So, is this calculator work?
Yes.
All right, what is it?
Log 81.
Log 81. And now, in your calculator, then if you close out the log 3, then add 2, you'll have the x.
6 equals 6.
Would you look at that?
Okay. Everybody get 6? Okay. Ruben, did you get it?
Yeah.
Okay. All right. Now here's another thing. This one, you might know, there's another way to do this one. Let me just show you that real quick. Because we're working with logarithms, we're actually doing this. All right, I know that this is 9 to the second power, right? But 9 is 3 to the second equals 3 to the x minus 2. All right, what's the exponent here? 2 times 2 is 4. So that says that this exponent and that exponent is the same. So x minus 2 equals 4, x equals 6.
Magic.
All right, and there is a section that works without a calculator. And without a calculator, that would be the way you would attack the problem. You would try to be able to say, in order for me to do this, this base and this number have to have the same base.
Right.
Okay? Back when the dinosaurs roamed, and we went to math class, that's how we had to solve this, because we didn't have all of the calculator support. And so we would have to, but the only problems we would get, this number and this number would be in the same base. That's the only problems we would get. All right, and what we've been looking at is numbers that is not necessary to do that. Okay, so let's go to 23. All right, log base 3 of x equals 5. Okay, this is a logarithm. Can you change it to an exponent form?
Yes, we can.
All right, we have an, okay. All right, Lauren, what do you do to change this to an exponent form?
You go 3 to the 5th.
3, very good. 3 to the 5th, because that's the base, and logarithms equal what? An exponent, so that's the exponent, equals x. Now, what do you do with that? That's just calculator work. Isn't that the XY button?
Yes.
Okay, so put it in. 9 times 27, 243. Okay. All right. base 4 of x equals, all right, Sydney, what happens here? Can you change it into exponent?
Yes.
How?
It would be 4.
4,
4 to the third
third power
equals x.
equals x. You should know that one by heart.
It's the only
Shame
one.
on you. What is it? What is it, Ruth?
You put me on the spot.
Okay, you're under pressure. What do you think it is? Huh? It's not 16, it's 64. It's 64.
Oh yeah, that makes sense.
Okay? Alright, okay?
You were close.
Alright, so next one. Okay, now, can't do that here. Okay, now I will give you a hint on this one. This one should have been in blue.
Because the logarithms have to equal each other.
Because so if this number does not equal this number, then that thing is absurd.
Oh wait, so x equals 50.
So x has to be 50 because 2x has to be 100, so x is 50.
Yep.
That's the easiest way to do that.
Problem 25, which is half of 50.
What?
Okay? Now, you have the 50?
No, it's problem 25, which is half of 50, which is...
Because of that too?
No. Like the problem number, like the actual number of the problem is problem 25.
That's okay. Yeah, that's all right. Very good. Very good. I didn't notice that. Okay. Now, another thing that I would have done on this problem. Oh, what did I do? What happened?
Oh, where is it?
Hit the reverse button.
Yeah, I know. I don't know what I did.
That's what he said.
Oh,
Okay.
there.
All right. Now, what I would have done to keep that from happening is I would have changed this base number to 619,
Right.
so that these two numbers were not confused. Right. That's the only fallacy I see in that one. Okay. Now, all right. We haven't worked that much with LN, but what has to be true here, and what color should it have been? It should have been blue. Because this has to equal 7. So, did I even need the ln? No. So, if this is not 3, then again, we have an absurd problem. Absurd. Okay?
Absurd.
Alright, now. Okay, so 27. Now, is 27 going to be in blue?
No.
Why?
Because there's no other...
Because this side doesn't have log 3 on it.
Yeah.
Right? So therefore you have to do what?
Math.
You have to do math. There we go. Okay. So what sort of math are we going to do? Okay, so you have to convert this back into an exponent. So it's 3 to the second power. How much is that?
3 to the second?
Yeah.
6.
9. So 9 equals 2x plus 1. Subtract the 1. Get 8. Divide by 2. 4. 4.
Oh.
Okay, what happens here? What happens here?
Very similar thing.
Yes. 5 to the
25.
25 equals x minus 10, add 10,
35.
35.
What magic?
Okay, what happens here?
Oh, ooh, you do the logarithm. And
All right,
base.
okay, you can do log base 3
500 equals
of 3x equals log base 3 of 500. Log base 3 of 3 is 1, so that makes 1x equals, and, all right, Aria, what do I do with this?
With log 3,500?
No, not the log of 3,500.
No. I was saying log log 500 divided by log 3.
Very good.
Yeah.
Log of 500 divided by log of 3.
Right.
Okay, is equal to x.
Right.
Okay? Man, what time be it? It's 8. You still have to work.
We do.
We got more time. All right, now, okay, here's what I want you to say. Tell me. All right, how hard are these to do?
Not hard.
They are not hard, provided that you keep those skills in mind. All right, the conversion between functions The conversion between the exponent form and the log form is important to know. All right? The identity rule is important because sometimes to get at the x, you have to insert log to some base.
Right.
And then the conversion rule we use. Now, I think chapter 12 is all conversion rules. Right? Because you understand the conversion rules, my suggestion is do a couple of those problems and say, I can do this. Right? Because if you know that they've given you this and they ask you for the answer, how many times do you have to do that to be able to do that?
Like 5.
Right? And you've already had the practice in here. So chapter 12, that work, I would, if I was going to save any time, I would save time on that because you can do it. Right? Yes, ma'am. Hannah?
Do we have to know the names of the rules?
No.
Okay.
No. I don't think I've seen anything. Okay, now, I'd like you to turn in your book to page 279. Turn in your book to 279. Isn't that cool? See, I'm an experienced teacher. The first time I told you to turn in your book, half of you weren't even listening to the page number. So when I said it the second time, I probably picked up all but one. And so the third time somebody was like, oh, page? What page did you say? Okay. All right, 279.
I'm players.
Okay, problem 11. Now, I will tell you this. Problem 11 is a classical problem because what they're going to do on the bottom of the previous page on 278, they give you the log of 2, the log of 3, and the log of 5 as numbers. Now, again, back in the dinosaur days, this is how we were tested about whether or not we understood the rules for logarithms, because there was no calculator. Okay, now here's my question. Problem 11 says to do what? All right, remember, and it says to do what? The log of 2 divided by 3. If the exponent is divided, what do you, if the number is divided, what do you do with the exponent? Subtract them. So this will be log 2 subtract log 3. All right, go to the bottom of the other page. So you're going to take 0.301 and you're going to subtract 0.477.
Equals negative 0.177.
And whatever it is, right? And again, when we were doing this, we had to do the math by hand as well. Right? At least you can use a calculator to do that. Okay? So, problem 13. Now, the only things you have are log 2, log 3, and log 5. That's the only information you know. So, therefore, what is 10? Isn't 10 2 times 5?
Yeah.
So what will I do with the log of 2 and the log of 5? You better say, add them. Right? And so in this case, you're going to take 0.301 and you're going to add 0.699. Because those two numbers as products means that you add the exponents. Okay, now what do you do with 15? What's 15? Log 3, right, plus log 5 will equal log 15. Because 3 times 5 is 15, right? So what will you do with that? You're going to add 0.477 to 0.699 and get whatever it is. All right, now here's another question. This, the problem that we just did, problem 15, it's log base 10 of 15. It has to be greater than 1 because 10 to the first power is 10 and 10 to the second power is 100. So the log of 15 is going to be between 1 and 100. right? So it'll be between 1 and 2 as an exponent. Now, look at 23. Look at 23. What is it?
Log.
It's the log of 30. How do you get 30? Because all you have is 2, 3, and 5. So what is 30 as a product? Factor it. You can do 30 is what? 3 times 10, isn't it?
Mm-hmm.
So, but what's 10?
2 times 5.
So I have 3 times 2 times 5. So what will I do with the exponents?
You add them.
Add them all. So you'd end up adding all 3 of those numbers. Okay, now, by the way, that's part of your homework. Okay, make sense?
Mm-hmm.
I hope. Do we go to 20 or 40?
20.
20, okay. All right. Okay, turn to page 285. 285. All right. Reuben, his heart just started beating again. All right, Reuben, 285, problem 5. Can you put it in the calculator?
Yes.
As what?
Log of
That number.
divided by log of 5.
Very good, excellent. And so you put log of that number divided by log of 5, whatever it is, you write it down and move on to the next problem. Okay, so you see what this is the section I said you don't necessarily have to skip. All right, now look at 13. Look at 13. Okay, what do you notice there, Carissa, as you're laughing? All right, read the problem.
Log base 49 times 49 to the 8th power.
All right, log base 49 of 49 to the 8th power. But what is log base 49 of 49? 1. And so what are you going to be left with? You're going to be left with 8 times 1. Because the exponent rule says that 8 goes in front, right? And so it'll be 8 times log base 49 of 49, which is uno. So 8 times 1 is 8. So that answer is 8. Okay? Look at 14. Look at 14. What's the answer? If it's log 64 of 64 to that power.
The answer is that power.
The answer is that power, 5 over 6. All right, look at 15. Now, the 3 has to stay there. 3 times that power, right? Because the 24, the log of 24 to the base of 24 is 1. Now the 3's cancel, and you're left with negative uno, 2-0. Negative do-o.
Negative 2-0.
Negative do-o. All right? Okay. So, because the 3's cancel, you're left with negative 2.
Yes.
All right? So, what happens is 16. You have 5 times...
9.
Yes. Say it loud.
5 times 9.
5 times 9, which ought to be 25.
5 times 9?
35? 45.
Yeah, I was gonna say it was like 25.
Yeah.
I did that.
Yeah.
I did that on purpose. I have a 5th grader that would have taken 25.
You're like, okay, yeah.
Okay, how are we doing? 17. Whoa, don't get hurt. Don't get hurt.
Please don't get hurt.
Okay. All right, now turn over in the book to page 286.
Well.
Okay, now look at 27.
27. Change of base.
Change of base. All right, again, you already did that. You got that down, right? Okay. The reciprocal, number 29, we don't use that much. We don't use that much. Because what we would do, we would say log of B divided by log of A.
Right.
Right, we would use the change of base number on that one. That one is there, but it's rarely used. The only time that you would see that used is when they ask you which of the first is this second one also equal to. All right, and the change of base formula, I've never seen that on a test, other than the test to be able to say, can you do the reciprocal? All right, now, okay, look at the product of two logs. Now, do you notice the transitive property there?
Yes.
Okay, the first one will be log of b divided by log of a, right? And the second one will be log of c divided by log of b, and the two b's cancel, and so you're going to have log of c divided by log of a, which happens to be that first one. So you don't need this rule, you just interpret the two of them directly.
Right.
Okay, the same thing with three products. Okay, so that's one of the reasons why we skip those things. Right, is because your change rule, your base change rule will allow you to get all those without having to know them. Okay? All right, thank you for working hard today. Hopefully learning well as well. Okay? All right, so we'll turn this off and have a good day.
Alright, so it's nap time, right?
Yes.